Problem 6-116. Sketch the graph of y equals log base 3 of the quantity of x plus 4 and describe the transformation from its parent graph. I'm going to take the opportunity on this one to go back to the basics of how to graph logarithms without using the calculator. I noticed some of my students were struggling in class to remember how to do it, so I'm going to use this opportunity to refresh. So this one might be a little longer here. If you feel like you understand that part already, you can fast forward through it. You have the power to do that. First of all, remember a logarithm or a logarithmic function. A log function is the inverse of an exponential function. So a log function is the inverse of an exponential function. The reason I bring that up here is when we look at something like, and let's look at the parent graph first. We're going to focus on the parent. The parent graph of this function here is going to be y equals, that is not an equal sign, y equals log base 3 of x. Okay, so right now remember this is in what we refer to as log form. Okay, if I wanted to put that in just exponential form, not turning it into an exponential function per se, just exponential form, okay, still a log function, I would take and I would say, all right, 3 is going to be raised to the power of y to equal x. So that would be 3 to the power of y equals x. Okay, that is still the same function there. This is our parent function. But if I wanted to go to the inverse, and remember the inverse is a reflection over the line y equals x. Okay, then I would have to flip my x's and y's. So what I would end up with there is 3 to the power of x equals y. So what I'm going to do here is I'm going to make a couple tables. I'm going to make a table for my inverse function, which is my exponential function, and then I'm going to make a table for my parent function, the one that we actually started with here. So I'll try to properly label all of these here. Make sure everybody's good with that. So this is going to be my parent function. Actually, let's move that. Let's actually do our inverse one here on the left. This is going to be our inverse. And by that I mean this is y equals 3 to the power of x. Our function up here, we're more concerned about 3 to the y equals x, or y equals log base 3 of x here. So this one's going to be y equals log base 3 of x over here. So this one will be easier for us to start with, and then we can just flip-flop our x and y coordinates there between them. So if we were looking at y equals 3 to the power of x, let's just go ahead and put some values in there. Let's put some negatives. Let's put some positives in there. So if I put in -2, I'm going to end up with 1/9. If I put -1 in here, I should end up with 1/3. If I put in 0, I should get 1. When I plug in 1, I should get 3. 3 squared is 9, and 3 to the 3rd power is 27. So now when I take this here, if I wanted to graph my log function here, remember I'm going to take it and I'm going to flip-flop my x and y values. So my x would be 1/9, 1/3, 1, 3, 9, and 27. And then I'll just record all my y values down as well. It'd be -2, it'd be -1, this one would be 0. We've got 1, 2, 3. So in order to graph the parent function here, remember this is the parent. This is the parent. You can take it here. Let's get out a coordinate plane. And let's make it a little smaller here, right? Probably a little big. Okay, so let's graph. Let's go ahead and we can graph our parent function now. Remember, we're not really graphing this. We just came up with the inverse here. Remember, the exponential would come up and it would end up going up, shooting up like this. That's the exponential function. We're doing a log function, so that would be this one here. So if you need to plot your points on there, let's do them in red here. So we're plotting these in red. We've got 1/9, which is really, really close to our y-axis, and then -2. Remember, we're going to have this asymptote that runs up and down here. We're going to have 1/3, -1. We're going to have 1, 0. We're going to have 3, 1. So 1, 2, 3, 1. We're going to have 9, 2. So we're all the way over to 9 up 2. And then 3 doesn't even, this last one's not even going to fill out. It would be 27 down and 3 up. So we're going to be looking at, I'm going to try to draw this in. Remember, this never touches the y-axis, and that's not going to be good enough for me. Let's see, let's make it a little thinner to give myself a chance, but it's going to come down, it's going to go down the y-axis, it's going to come up, and why is this so hard to draw on? Good Lord. It was close enough there, so let's just roll with that. Let's not roll with that, though. So and this is going to, remember, it's going to go down the y-axis here. So it comes up here. It's supposed to go through the points. You probably have more control over that than I do. And it goes out and shoots out this direction here. Oh my goodness. Let's just make it look like a giant arrow. So whatever. That's terrible. That is terrible. Whatever. I can't live with it. Notice I have problems? Yeah, I do. I'm called a perfectionist. That's not even close. Anyway, I'm wasting your time, I'm wasting my time. All right, there we go. That's a little bit better. So, anyway, so we've graphed this here. Remember, this continues on down the y-axis here. Now, it's asking about the transformation from its parent graph here when we take it and we add 4 here. Well, our general function our general form of that function there, remember, is going to be y equals a times log base b of x minus h plus k. And just like with all of our functions, it follows the same rules. hk here, remember, is going to be a locator point, and h is going to affect the horizontal shift, how far left and right. It's going to translate it up and down the x-axis. K will translate it up and down the y-axis. So as we look at x plus 4, that means that if we have x plus 4 in here, that means we are going to translate left 4 units. So what ends up happening here is this asymptote that we've got here. Oh, that's going to not be able to be visible. Let's do, remember, we've got this asymptote that runs right down here. Okay, and the asymptote for this function here is going to be where x equals 0 our asymptote. Over here, we've moved it left 4 units. So we're moving it left 4 units, which means that our new asymptote, and we'll do that one in blue, will end up being x equals, think about going left 4, you'd be back 1, 2, 3, 4, you'd be over here, so x equals -4. So let's go ahead and put that in there. 1, 2, 3, 4. We're going to have an asymptote that runs right down here where all the values of x are -4. So when we take our values here, it'd be like we're subtracting 4 from each of them there, moving it back 4 units. So we'd end up with our new function here. Let's see, let's pick a different color that we haven't used. Let's use, say, orange. That one's nice. Okay, it's easy as taking it and moving them back 4 units. So if we were here, we're going to go back 1, 2, 3, 4. That was, then we're going to go back 1, 2, 3, 4. We're going to go back 1, 2, 3, 4. This one here, we're going to go back 1, 2, 3, 4. This one we're going to go back 1, 2, 3, 4. And you'll see here that we'll end up with a graph that looks like this. And it's going to continue right down the asymptote here. So it's going to end up translating it left 4 units. Remember, that just follows the same rules as the general form of our equation. And let's see, did we cover everything? We sketched the graph. That's this one here. This one is graphed in orange. We graphed our parent function there in red. It's the one with the green asymptote. This is the one with the blue asymptote. Hopefully that helped you out there. You know, you got to make sure you remember how to do the basics there. The calculator's a great thing, but if you don't remember how to do it without the calculator, sometimes that can cause problems. That means you don't fully understand it. All right, so this is problem 6-116. If you have further questions, make sure you ask your teacher. Thanks for watching.